My name is Dave Shanley. I'm the lead engineer of the new EVO Rail Hyper-Converged Infrastructure appliance from VMware. This man, of course, needs no introduction. He is Mr. Duncan Epping, who is our principal technologist. And we're going to give you a little bit of a deep dive into some of the technology, processes, and techniques that we've used to create the product, and talk about both the software and the hardware side of it. And at the end, we'll do a demo. It will be the same demo that we've been done in previous sessions, except I'll be pausing it at certain points to talk about it in more detail. That's for something. So, I specialize in software. I specialize in experience, to be exact. And we've all seen stuff like this before. This is what typical enterprise software looks like, and we threw in a picture of what a consumer product looks like that mimics enterprise experience. Buttons, controls, lines, input boxes all over the place. Confusing, and it's a nightmare to navigate. And I can't stand this. I want to create something better. I want to see enterprise software be treated the same way as consumer software is. So I'm going to hand over to Duncan, and he's going to give a little bit more information.
Yeah, let me start off with a question. I started out as a consultant and as a sysadmin, and this is the typical data center that I saw back, about 10, 15 years ago. So I'm wondering who's seen the same type of data centers in the past? That's quite a few hands, and I think you were all frustrated by the amount of wires going from left to right, all the physical boxes, and especially the number of physical boxes made it really complex to manage your environment, right? So your data center. So, after a couple of years, VMware came out with an awesome piece of technology called Workstation and GSX. Based on that, we developed a product called ESX, and you started virtualizing your physical servers, and the data center kind of started changing. But throughout the course of the years, we started noticing that it didn't change enough, at least not from my point of view. And that's more or less what we're going to talk about today. What are the changes that we can make to the data center to make your life easier as a consultant, but also as a customer, or potentially as a partner. So if you look at the sessions you've probably seen in the last couple of days, I think the majority of sessions will probably be about the software-defined enterprise or software-defined data center. Now, the majority of those sessions will actually focus on the VMware software that runs on top of the infrastructure. But most of the sessions won't actually go into any details around how to set up this infrastructure itself or how to manage the infrastructure. How do you create building blocks, and how do you scale out or how do you scale up? And this is typical where a lot of these sysadmins spend a lot of time when it comes to creating new environments or creating architecture itself. So there's a lot of challenges when it comes to that. First of all, you need to figure out where to begin. What kind of data center do I want to build? What are my applications? What kind of workloads will I be running? And how will I be provisioning these types of workloads? So those are some of the typical challenges that you will see in data center environments. Now, besides creating architectural designs or provisioning virtual machines, of course, there's also the lifecycle management and support aspect of data center environments. Things like troubleshooting, for instance. If I have an issue in my environment, is it an issue of my switch? Is it something within my storage system? Or maybe it's an issue within the VM kernel, or maybe even the virtual machine. You typically end up phoning up multiple partners, and they all start pointing at each other, and before you know it, you're 15 days down the line while your manager is breathing in your neck, and he wants you to solve the problem. So this is, in my opinion, where converged solutions or hyper-converged solutions come into play. So let's talk about the three different approaches that there are for building a software-defined data center. As I've already mentioned, in the past, we would pick up multiple components and build your own type of data center. So you would look at the hardware compatibility list that VMware provides, pick your favorite server, pick your storage system, and you would connect them using networking components, and you would end up with an infrastructure. On top of that, you would start layering your services. Now, trying to figure out which components actually work well together is a difficult job, especially when you start looking at these larger environments. If you're doing 10 hosts, it's relatively easy, but if you're doing 5,000 hosts, you can imagine that the type of issues you start hitting when there's compatibility problems are significant or can be significant. So a couple of years back, a new type of infrastructure was introduced, or at least a new type of solution was introduced, which is called Converged Infrastructures. And I think probably the V-block is one of the best examples of that. So converged infrastructure is basically all of the components pre-packaged sold as a single SKU, and also pre-tested. On top of that, if you look at support, for instance, that typically also goes through a single support call or at least a single phone number. A couple of years back, some of our partners developed a solution which is, from a conceptual perspective, a smaller solution than the converged infrastructure. It's something that they titled Hyper-Converged. Conceptually speaking, as I said, it's the same as a converged infrastructure. The big difference being, though, the building block, or at least the size of the block itself, is a lot smaller. I've just mentioned the V block as the biggest example, and I just wanted to shortly or briefly allude to why people are interested in buying these converged infrastructure appliances or rack-type solutions. First of all, ease of procurement. So most of the customers that we've been talking to, and especially the large enterprise customers who end up buying these types of solutions, most of the feedback that we received is it's very easy to procure these systems. Why? Because I don't need to contact 4 or 5 different vendors to start building out a full data center. Within this single system, you'll have your storage included, you'll have your compute nodes, and you'll have your networking as well. That includes typically both fiber and just regular Ethernet connections. On top of that, when it comes to scaling out or scaling up, these building blocks are typically an easy way when it comes to replicating the environment. So it's very simple to add new or add additional capacity. On top of that, when it comes to managing these solutions, because it's an integrated solution, and the vendor typically makes sure that you will have the tools and components available to manage it, it reduces a lot of the complexity when it comes to monitoring these environments and troubleshooting them on top of that. Now, the one thing I want to emphasize is a converged infrastructure is not what I would call a product, but it's a solution. And the reason I would call it a solution is because it's typically comprised of multiple components of different vendors. So in this case, for instance, you would see that it's EMC storage, Cisco networking, Cisco UCS compute nodes, but on top of that, there's also an operating system installed or a hypervisor, preferably. Now, I mentioned that the building block approach will simplify the scale-out mechanism, but besides simplifying the scale-out mechanism, I think an important aspect of the building block approach is the cost factor. When you start managing your environments and start architecting them using a building block approach, you will notice that from a management perspective, all of your hosts will hopefully look similar, and all of the blocks that you start adding will need to be managed in a similar fashion as well, so the cost should automatically go down. On top of that, as soon as you start scaling out in a building block fashion, what you will typically see is that you will get the same results from a performance and availability perspective. So if your first block delivered 5,000 IOPS, it's more or less guaranteed that you can expect the second block to deliver the exact same resources. Now, I mentioned the converged infrastructure solutions, and I think there's one disadvantage of these types of solutions, because they typically only fit in a certain space. So depending on the size of your company, depending on the amount of hosts that you will need, it either will work very well or it's going to be way too expensive. And that's, in my opinion, where the hyper-converged solutions come into play. So a hyper-converged solution, as already mentioned, is very similar to a converged solution, with that meaning that, similar to the converged solution, it's a one-stop shop. So you contact a single vendor, and he'll be able to provide you the solution, and it's typically pre-configured. It will be sent out. You should be able to, or at least get it up and running in a couple of days, or potentially even hours, depending on which solution you're buying. Now, this also means that if you compare it to the traditional way of doing infrastructure, that from a time to value perspective, you will be able to run virtual machines within a couple of days instead of a couple of weeks. On top of that, if you look at these types of solutions, as I said, the scale-out mechanism will help, but also the ease of management. So typically what you will see with these types of solutions that are fairly easy to manage, they will come with specific monitoring tools, management tools, and they are fairly simple. Another key differentiator between the hyper-converged solutions and the converged solutions is the storage aspect of things. If you look at the converged infrastructure solutions, what you will see is they will typically come with what I would call a legacy type of storage system. So it's a big storage system with a lot of spindles or potentially even flash, depending on what type of block you build, or at least you buy. But that's different with the hyper-converged solutions. The hyper-converged solutions are typically enabled by what's being called by the market as a server SAN solution. About a year ago, and hopefully everyone has seen the announcement, VMware introduced a new product called Virtual SAN. The nice thing about Virtual SAN, which actually is a server SAN solution, is that it's very easy and simple to enable. Hopefully every one of you have done the lab, but if you've done the lab, you would have seen that you can enable it in 2 clicks. Of course, there's some stuff that will need to happen from a networking perspective, but in terms of configuring Virtual SAN itself, it's pretty much straightforward. I think the big advantage of Virtual SAN when it comes to a storage point of view, when you look at it from a storage point of view, is the management aspect. So a lot of people start talking about the fact that you can enable it in 2 clicks, and that's really nice, but you will only need to enable it once, right? The cool thing about Virtual SAN, for instance, is that it will enable you to start doing virtual machine-based management from a policy perspective. In other words, if you look at a traditional storage environment, you'll have multiple LANs, and when you create a virtual machine, you will need to pick a LAN. With Virtual SAN, that changed. With Virtual SAN, we introduced a mechanism called storage policy-based management. So as soon as you create a virtual machine, which ends up on Virtual SAN, you will end up picking a specific policy. And the nice thing about that policy is that the policy will determine what the availability is of your virtual machine, but for instance, also your performance. So if over time, for instance, the characteristics or the requirements for your virtual machines change from an application point of view, so we need to have multiple copies of your data available, or for instance, you will want to have additional read cache, you just tweak the policy itself, or you assign a new policy to your virtual machine. And if you have 500 virtual machines that you would like to change, you can also do that through the APIs, or simply by connecting a new policy to those 500 virtual machines from within the UI. So it's a fairly easy mechanism of managing your virtual machines, but on top of that, managing your storage. From a performance perspective, if you look at Virtual SAN actually sits within the VM kernel. So that means that from an overhead point of view, we don't need to go up and down to virtual machines to do I/O. It's from the virtual machine straight down to the disks. And it also leverages a flash solution. So every single Virtual SAN node will require a flash device. And what it will do is every single write will go to flash. So from a write perspective, you won't have a lot of overhead. It won't be hitting the disk first. It will always go to the flash device first. And from a read perspective, 70% of the flash device is actually used as a read buffer. So the majority of reads hopefully will come from your flash device. On top of that, from a Virtual SAN perspective, and I think that plays well with the Hyper-Converged approach, is as soon as you start adding nodes, you will see that the system will start scaling in a linear way. Now, of course, there's also the cost aspect. It's a grow-as-you-go solution. With that meaning is that you don't need to pay up front for a certain amount of capacity. So if you expect to have 20 hosts at some point in time, but you only have 5 hosts right now, that's the capacity you will need to buy. From a cost perspective, it's also very easy to manage, so the management cost should go down, and you're leveraging local disks, so you're not using an expensive legacy storage array. Now, traditionally, or at least for the last year, VMware offered Virtual SAN in 2 different ways. If you look at the first approach, which is the Virtual SAN built from the hard compatibility list components, I think it's probably the most complex solution out there. The reason for it being is that you as an administrator or as a consultant need to know what all of these components do and how they react to failure, but also what they look like from a performance aspect. If you look at the HCL approach, what you will need to do is you will need to pick a server from the HCL, so just a regular vSphere HCL. You will need to go to the Virtual SAN HCL. You need to figure out which disk controller to use that actually fits in that system. On top of that, you will need to figure out if it meets the Virtual SAN requirements. Then you will need to start looking at the different disks, how they align with the disk controller, if they meet your performance requirements, and then of course there's also the flash device itself. So there's a lot of moving parts, and I can tell you that out in the field I've seen many people doing this successfully. There have also been some customers that more or less burned themselves because they picked the wrong disk controller, and the disk controller only had a queue depth of 25 instead of the 256 that it was supposed to have. Now, what VMware did to simplify this is that they introduced a new concept called Virtual SAN Ready Node. And basically what a Virtual SAN Ready Node is a configuration predetermined by the server vendor. They picked all the components for you, and they more or less what they did is from a certification perspective, they tested these components together as well. So they typically integrate well, and they should perform well as well. Now, when we started looking at these types of systems, we had some discussions with customers, and the feedback that we received from customers is, the virtual SAN-ready nodes are pretty cool, but I still need to configure it myself. I still, need to talk to multiple vendors when it comes to support. Is there any way we can do to solve these problems? And that's where the EVO Hyper-Converged infrastructure comes into play. So let's start talking about EVO a bit more in depth. Hopefully all of you have seen the keynote, and I think Ben Fathy and Pat Gelsinger explained it in a simple way, and they alluded to what's included. One thing that was missing is some of the software components that was included. But first of all, let me explain what EVO itself is, because I'm going to guess that the question is going to come up at the end of the session. So EVO from a VMware perspective is a build recipe. What we did is we created a build recipe, we created a software engine, and we provided that to our partners to enable us, or to enable them to start selling a hyper-converged infrastructure appliance. Now, this appliance is actually built on top of trusted technology that VMware has had for years. So vSphere, of course, is included, so ESXi in both vCenter. Virtual SAN is included, log insight, so you have more in-depth detail around what's going on from a logging and auditing point of view. And on top of that, we provide the EVO engine as well. Now, all of this is combined in the 2U unit. So from a form factor perspective, we just saw the big rack from a hyper-converged or from a converged infrastructure point of view. The EVO hyper-converged infrastructure appliance is a 2U unit with 4 individual nodes, so 4 independent nodes. Now, besides, of course, all of the cool stuff that vSphere will already provide you, we added a lot of, in my opinion, valuable features. So things like, for instance, non-disruptive patching and upgrading. So there's no longer a need to use Update Manager, but for instance, also auto scale out. I've already alluded to the route to market, but I wanted to emphasize this a bit more because we've been getting a lot of questions over the last couple of days. How does this actually work from a VMware point of view with partners and then the customers as well? So look at it from this point of view. From a customer side, what you will do is you will contact one of the qualified partners. What the qualified partners will do is they will build and they will create these hyper-converged infrastructure appliances based on the requirements that we provided them. So what does this bring to you as a customer? First of all, and Dave is going to show you a cool demo at the end. First of all, simplicity. I think the demo is going to show you, that the system is really easy to set up. It takes about 15 minutes, 12 to 15 minutes. So the whole management aspect will radically change. On top of that, of course, there's the single SKU aspect. So when it comes to procuring these types of devices, you don't need to buy multiple components because all of the licenses, for instance, are included. And that also includes support, by the way. So when it comes to support, all the support will go through the OEM vendor, and they will do support for both the hardware components, but also the software components. So if there's anything wrong with your system, you don't need to phone up VMware and your hardware vendor. You'll end up with a single support call, and hopefully they'll be able to solve all your problems in a reasonable amount of time, instead of being bounced between all of these different vendors. And this is where Dave takes over.
Thank you, Duncan. Oh, am I on? Yes, I am on. So, the point to EVO, from my opinion, is to create a transformational user experience. Move forward here. So I'm going to talk about some of the core technology that we use to build the product and some of the strategies that we took to do it as well. So you'll be pleased to know, I hope, that it's pure HTML5. JavaScript, CSS, WebSockets. No Flash, no Flex. It's ultra lightweight, it's really fast and responsive, it's snappy, it's not laggy, and it kind of responds in real time. We've stripped away a lot of the heavyweight features that are provided by vSphere. Some of these things are really, really powerful, but they're not necessarily something you'd use every single day or that are core features of virtualization. We wanted to make it really simple to configure and manage virtual machines and upgrade it in a really simple way, and that meant boiling down the core features. It works great in IE10, Firefox and Chrome, on all platforms. As there may be some developers in the room that understand that IE can sometimes be a pain point, especially IE6. But we've moved forward, and now we've got great support across all our browsers, and it's the same experience. You don't need any plugins whatsoever. And this means it also includes the HTML5 VM console, so you don't need to have any plugins to use that either. It was built up from the ground completely from scratch. We used the best-in-class open source technologies and VMware technologies. We didn't use any third-party tools to put this together. This was a 100% engineering from scratch process. There's no moving parts to it. So because our disk technology is virtual SAN, it's baked right into the hypervisor, so we don't have any guest VMs running file systems. There's no additional databases either. The entire platform has been built using the vSphere and ESXi APIs via SIM and Vim. It actually sits right next to the web client in terms of architecture. So it's not stuck on top, it's not stuck on the side, it's integrated directly into vSphere. And one of the things that we do in our team is that we operate like a startup. This means that we can fail fast and iterate really, really quick. We have 2-week sprints. So at the end of every 2 weeks, we actually have a build that we can go out and distribute. Now, I'm not saying that that will be the case moving forward for releasing the product, but it means that we can respond to feedback really, really quickly. And a lot of the feedback that we implemented in just last month has come from our EAP customers. So I'm going to hand back to Duncan, and he's going to give you a little quick walkthrough about some of the features.
Yeah, we're going to quickly walk through some of the screenshots, because Dave is going to show this during the demo as well, but there's a couple of things that we wanted to emphasize. So one of the key things when it comes to deploying an EVO rail solution, in my opinion, is the time to value. So in other words, it will take as little as 50 minutes, and we've been able to do it in about 12, 13 minutes as well, or even faster, to start deploying these virtual machines, or at least start deploying virtual machines. So if you look at the screen itself, so what happens after you rect and stack the environment is you'll hit the web page itself, and you're nicely greeted by the EVO rail engine. What you will do is you start customizing the environment itself. So first question you will typically get is, what do you want to do with your host names? Now, what we've seen in the past is that, from a consistency perspective, if you make a mistake in a host name, it becomes really difficult to start troubleshooting your environment. So what we did in the UI is we actually provided a mechanism to actually mention or specify a naming scheme from a host name point of view. On top of that, for instance, you can also specify IP ranges. So instead of specifying individual IP addresses per host that you're going to add, you'll just specify a range, and when host gets added, they will use an IP address from that range. Now, when you're done configuring the whole system, what will happen is we'll provide you the option to validate the environment, or at least the configuration specific that you provided. With that meaning that if you have an IP range which doesn't align with the subnet mask that you provided, you will actually see a nice red check mark up on the screen. Well, now when you're done and you click build, the whole process will take about 9 minutes, and it will automatically configure all of the components which are part of the appliance. So that includes ESXi, VC, virtual SAN, and log insight potentially if you've enabled that. Now, what in my opinion is truly unique about this interface, and this is something that Dave and I discussed multiple times, is how do I start configuring things like NTP? Because if you look at the current platform that we offer, so ESXi and vCenter itself, but also log insight and potentially some of the other components that may be added in the future, all of these components when it comes to things like NTP, DNS, proxy servers, you will need to individually configure these. So in other words, if you need to send an NTP address for an ESXi host, you will need to do that on the host itself. Then you will need to do that on the VC. And if you have many hosts, you will need to do that on every single host individually. So what we added is a screen that provides you with the ability to specify these global settings. So you will set them once, and every single node that's added will get these settings automatically. On top of that, when you had your first appliance up and running, and at some point in time you end up out of resources, you actually have the ability to automatically scale out. What that means is that if you procure a second system, you have it racked and stacked, it's powered on, it pops up on the network, There's a service running on all of these nodes, which is called Loudmouth, and the service literally screams to the network, hey guys, I'm here, what do you want to do? So what happens is, those systems will pop up in the EVO Rail engine, or at least the EVO Rail interface. And at that point you can decide, I want to add them to the existing cluster, or I potentially can create a new cluster as well. But typically what we expect most customers to do is pull them into the existing cluster. That takes about 6 minutes.
Yeah.
The nice thing about this is that you don't need to start pre-configuring everything or specifying new IP addresses, because you've already specified these IP ranges, right? So that takes a split second to actually enter the passwords, and you can go on. Now the key thing here though is that it uses the peer awareness functionality that's part of IPv6. So from a networking point of view, you will need to make sure that IPv6 is enabled. On top of that, it will use multicast DNS, so this is also one of the pieces of functionality you will need to make sure it actually works in your network. Now, one of the feedback that we received from our early access program customers was, what about patching and upgrading? And of course, we are all aware of some of the constraints that the Update Manager solution has. I've used it many times in the past, and I think from an enterprise perspective, it's a solid solution, but there is a big constraint around it, which is basically the Microsoft operating system. Now, what we just mentioned is that we actually use the vCenter appliance itself, which is based on Linux, and it doesn't support running Update Manager at this point in time. So what we had to do is build a new mechanism that allowed us, from a Linux perspective, to actually start patching and upgrading these ESXi systems. So what's included in the EVO Rail engine is a solution that automatically and non-disruptively patches your ESXi nodes, your VC, but also the EVO Rail engine itself. Now, when you've done all the configuring and you're done with patching and upgrading potentially, of course you will need to start managing or at least creating virtual machines. So one of the things that we wanted to make sure is that from an experience perspective, if you look at creating virtual machines and you use the web client, there's still many choices that you will need to make. Well, we reduced the complexity as well when it comes to virtual machine management. So as you can see, it's a full new interface. Now, of course, the interface is not going to be as feature-rich as the web client itself, but you should be able to do most of your daily tasks within this interface. In my opinion, it's a highly intuitive interface, and it will allow you to create a virtual machine within a couple of clicks. Now, besides creating virtual machines, of course, you also want to know what the state of your hardware is. So we provide a lot of details when it comes to monitoring itself. I think one of the cool features that actually provides, which is really difficult to see within the web client, is the amount of storage that is provisioned in total, both from a total capacity point of view, so from a physical point of view, but also from a virtual point of view. And hopefully, as all of you know, Virtual SAN actually uses a thin disk format, which means that as soon as you start adding multiple or a lot of virtual machines, you could end up in a scenario where you're over-provisioning your virtual SAN environment. And I can tell you that you don't want to fill it up, because bad stuff is going to happen, and I've seen it in the past. So the UI will actually alarm you about that as well. It will warn you about the fact that you're over-provisioning and that you will need to start scaling out. Now that we know that the interface is really simple and it's really easy to manage, what about some of the specifications? What does the performance look like? If you look at the EVO Rail specifications, as I've already mentioned, it's a 2U appliance with 4 individual nodes, and each of these nodes will come with the Intel E5 2620 6-core processor, or 2 of them actually. The nodes will have 192 gigs of memory, 3 1.2 terabyte disks. These are 10K RPM SAS drives, so we actually try to guarantee a certain amount of performance when I/O needs to come from disk. Of course, they will need to have a flash device, which is used for I/O acceleration when it comes to virtual SAN, and it also uses a 10 gig, a dual port 10 gig NIC device, and it has an IPMI device for management as well. Now, if you add all of these resources up, and you can see that on the screen, those are significant numbers: 768 gigs of memory, 100 gigahertz in terms of CPU capacity, 14.4 terabytes worth of storage capacity, which comes in around 13.1, 12.9 raw capacity after virtual SAN, or at least vCenter has been deployed and Log Insight has been deployed. Now, I've already mentioned that the systems itself will contain a 10 gig network, and the reason it contains a 10 gig network connection is because of virtual SAN. Now, virtual SAN doesn't actually require a 10 gig network, but it's highly recommended. And the reason it's highly recommended that if a failure occurs, new copies of your data will need to be instantiated, and at that point in time, you will see a lot of traffic. So if you have a 1 gig network, that will take a very, very long time. So within the hyper-converged infrastructure appliance that we offer, a 10 gig networking card is included to make sure that from an experience perspective, when it comes to performance, even during failure, we can still guarantee a specific point. Now, we had a whole bunch of customers testing out these appliances, and one of the things that they experienced when it came to configuring these, because it only takes 50 minutes to set it up, but setting up the network, of course, typically takes a bit longer. So one of the requirements that a lot of people didn't seem to catch, which is actually a requirement of virtual SAN itself, is the layer 2 multicasting that needs to be enabled. So if you're interested in deploying these devices, doing a POC, make sure that you enable layer 2 multicasting. On top of that, as I've already mentioned, in order to get the auto scale-out mechanism, IPv6 needs to be enabled as well, and it's also used during the configuration part, which Dave will show in the demo later on. So when it comes to performance, what we started looking at is doing some of these synthetic tests, and we ended up with pretty extreme numbers. And it's nice to show people that you can do 1 billion IOPS, but it doesn't really tell you a lot, because what does that mean from a virtual machine perspective? So instead, what we started doing is we started creating these desktop workloads and server workloads. So we had our view team looking at the appliance itself. This was tested by an external team instead of within our team. And what they were able to do is comfortably run about 250 Horizon View desktops on top of one of these appliances. And these desktops were using 2 vCPUs, 3 gigs of memory, and a 30 gig thin disk. Now the question that then typically arises is, why is there a difference between the 250 desktops and the 100 server virtual machines? And the key reason for that is that virtual desktops typically will use the link clone technology. So the amount of gigabytes that they will consume from a storage perspective is a lot lower than for a server virtual machine. So for a server virtual machine, the numbers look slightly different, but of course it's going to depend on the type of resources that you normally assign to your virtual machine. So your numbers may vary. Now the question then arises, where can I buy one of these systems? Hopefully you've all seen the announcement, and you can actually see these boxes in the EVO zone on the show floor. There are boxes from Dell, EMC, Fujitsu, Inspur, Supermicro, and Net1. And with that, I'm going to hand it over to Dave again to show you the technology in the demo.
Thanks, Duncan. So what I'm going to do here is I'm just going to play a video and narrate over it, and I'll pause it in certain places to talk a little bit more about some of the underlying technology. So, EVO Rail. Hello, this is me, blah, 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 blah. So the first thing you're asked to do is go. It's literally one button. There's only one thing you can do. You have to accept the EULA. We couldn't get rid of this, unfortunately. Had to keep it in the product. So EVO Rail comes with a just go option. These are a bunch of predefined settings and variables that you can have specified when you procure the appliance. It means that you can just go and everything will be done for you. All you have to put is the passwords we're going to configure. First up, DNS. The appliance comes with its own internal DNS server that allows fully qualified domain names without the need for an external DNS service. You can customize your DNS by configuring a host name, a separator, an iterator, and a top-level domain. Any changes that you make will be reflected in real time, so you can see how it will look when you build it. You've got control of your ESX, your vMotion, virtual SAN, vCenter server, and your VM networks. Now, to keep things simple, as Duncan said earlier, you don't have to configure each individual IP address. Instead, you create IP pools with a beginning and an ending IP. This allows EVO Rail to dynamically assign these IP addresses to its hosts. The minimum size is 4. This is because there are 4 nodes in an appliance. And if you want to extend your cluster at a later date, you should plan to increase your pool size by 4 per appliance you want to add. You'll notice as well there's no save buttons anywhere. This is because everything you do is saved and validated in real time. So as you're moving through the UI, it validates your settings, and obviously here we've got a problem. It shows you what the problem is in the categories and highlights each of the fields. So it tells you where to go to fix it and how to fix it. We've tried to make it simple to not break. VM networks, you can have as many as you like, and all you have to do is configure a name and a VLAN ID. So the only passwords that you're asked for are those for your vCenter server administrator account and your ESXi host root account. As I said before, there's no shadow database. EVMworld does not store any of these passwords. And you can configure Active Directory as well. Globals, these apply to absolutely everything inside the appliance. So you can set all your NTP and your DNS, if you have them, in one place. Logging, really, really simple. You can either use your existing syslog server, or we bundle log insight directly on the appliance. We'll set it up, configure it, set all its IPs, and get it up and running and connected to the entire environment without any interactive work from you whatsoever. There's a couple of other really useful tools on the config UI. You can upload an existing configuration file. This means that you can distribute. Let me just pause this actually here because this is quite important. The configuration file is something you can create yourself. It's really, really simple, basic JSON. And then you can distribute that across all of your different robos to have the same configuration for all of your different appliances without having to worry about getting things wrong. If there is a problem or if something goes wrong with validation or location, you can download the configuration logs right from the UI. No SSH, no console required whatsoever. So here, we validated the configuration. And this looks good. What this actually does is it does a deeper dive on your settings and all your IP pools and your subnet masks and your gateways and VLANs, et cetera, et cetera. And what it does is make sure that the settings that you've put in will work on the appliance. If there's a problem, like Duncan has said, you'll get a red orb and you'll be told exactly where to go to fix it. This also makes sure that it can talk to all of the hosts in the appliance. So if there's any problem with the host, you'll know before you start building. So we try to make sure that you can't configure this appliance incorrectly. So when you're ready, we start the build. And this is where all the really heavy lifting is done. This is actually the configuration engine of the EVO Rail. The UI shows you exactly which task is being executed down in the bottom right-hand corner, and obviously you can see the percentage up there in the left. And we've broken each of these stages down into four different categories, I guess. Initializing, building, configuring, and finalizing. The first two involve setting up DNS, configuring your host names, and also unpacking and configuring the VC server, because it doesn't come configured whatsoever. We have to set up SSO, set up the databases, and get everything up and running. It takes around 4 minutes. A lot of the time is actually configuring VC, the setting up of VC before we start configuring it. It takes a while. It's considerable. Next part is my favorite. It's the configuration stage, and this is where we start setting up all of our hosts and networking. Something interesting, as Duncan said earlier, is that these hosts are not configured. So normally to be able to configure them, you'd have to use an out-of-band management system or IPMI or a console or something like that. But we've built ZeroConf right into the very core of EVO Rail, and we call it Loudmouth. This allows us to locate and connect to all of these hosts, and they don't have an IP address. They have no networking configured whatsoever. They've got a linked local self-assigned IP, and it uses IPv6 to broadcast multicast packets all over the network to find these hosts. And once that's done, it takes around 4 or 5 minutes. We finalize, clean things up and put them away, and we're done. The entire thing has just been built, and it takes around 9 minutes. 15 minutes if you want to play around in the configuration UI. So moving on, we're going to go and take a look at the management UI. So something important here is this is not a replacement for the web client whatsoever. This is an enhancement to the experience of using and managing VMs. We made sure that we didn't break vSphere or ESX in any way whatsoever. This is a complement to those products. And I said there's no databases, doesn't store any of the passwords, it uses the Vim APIs. Here's our UI, and that's actually something I wanted to, I can't see it on the video, well, it's cut off, but on the top right-hand side, there's a vSphere icon. So if any time you want to get into the web client and do something a little more deep down that we haven't exposed in this UI, you can just click it and you're straight in. So let's go take a look at the health. As you saw earlier, we've tried to boil down the real core essentials to understanding health by both appliance and individual host. You can see here, we can see the power state, the host name, the disks inside the host, what type of disks they are, and how healthy they are. Anything that's not red is good. And you can also see the NICs that they're connected and the transfer speeds that they're running at. We've put in some real simple graphs and visualizations to show storage IOPS and provisioned storage, both from a over-provisioned state and your consumed state. So now I'm going to go ahead and create a VM. Made it really simple. Again, that's the whole point of this. First thing you have to do is upload a guest OS. Now you can do that via NFS or CIFS, or you can upload it straight from your desktop, and my preferred method. So I'm going to do that. I've got a tiny little ISO here. It's a 14 megabyte Linux distro. It is copied up to the appliance and then distributed over virtual SAN. Next thing we have to do is pick a guest OS type. And then we pick a size. This is something I wanted to just go down into a little more detail. These are not like a static set of sizes. We just didn't configure a small, medium, large. They're actually sensitive to the guest OS that you just picked. So obviously, a Windows VM, a Windows Server 2012 is going to be a very different configuration for a small VM to a micro Linux VM. And these settings have actually been fine-tuned by Duncan himself. So you know you're going to get the right settings for the VM that you pick.
Don't blame me though, right?
Again, it's just, there's some descriptions. It's just you can flick between them and see the specs and decide which one is going to be right for you. I'm going to pick a small one here, whenever the video catches up. And then next up is VM networks. You've already created them. You just have to pick which one you want to sit on. Pick as many as you like, or none. Well, you need one. So this is actually something that's a new feature that we've developed. It's actually taking risk profiles from our vSphere hardening guide, and we've put them into 4 different categories. They're actually 4 different risk profiles, well, 3 different risk profiles. And this feature was actually created by William Lamb, and he uses these advanced virtual machine settings all the time, and we don't have this kind of feature in any of our VM creation tools right now, and said it would be really nice if we could do that. So we did it. We just took those settings from the profiles and applied them straight here. There's nothing more to it. And the secure policy is like NSA type stuff, and it breaks some things, so you probably would be okay with a default or basic or no policy. I'll have to give it a name, of course. Can't create a VM without a name. And that's it. It tells you the specs on the left and how much of the progress on the right. And when it's done, the VM will just pop up on the grid, and you can start using it. There it is. So we're ready to start using the VM. How much time do we have left? Oh, okay.
You've got to watch.
I'll just keep going until they tell me to stop. So you can click on the VM to get more options. You can see the console, and there's a number of everyday power operations underneath. If I press play, it is playing. So I'm going to show just one of these features here. I'm going to rename the VM. Everything is done inline. You simply click it, type in a new name. Very creative, of course. Rename it. It's done. It modals the VM and shows you something's going on. When it's done, it tells you, gives you an alert, and that's it. So let's do another one very quickly. Let's clone a VM. The only thing we have to do is give it a name again. and just whether we want to power it on. Now this takes a little longer than a rename, so you can collapse it down and use other VMs in the grid, and it will show you what's going on with this particular VM. And it gives you a progress on the stuff, so you don't have to go and look at the tasks bar. It's all done in line, centered around the VM. And once it's cloned, it pops up on the grid, and you can use it just like any other. So let's go and look at patching and upgrading. It's as simple as uploading the bits you want to upgrade. So I'm going to upgrade the platform here, got the RPM, copies it up. And then of those bits that you've uploaded, you just simply pick the parts you want to upgrade or update, and this includes ESX and VC and the platform itself. You click update, that's it. Nothing more to do. Walk away, come back, you've just got an upgraded environment. Now, sometimes if you have a lot of VMs, it takes a while to vMotion those VMs off before we can upgrade the host. So you may get a different experience based on the workloads that you have running on the machine, but you will have there's no VM downtime whatsoever. So the last thing I'm going to do is look at expanding the appliance. As you rail in your new appliance and you power on all of the hosts, they start to beacon as they come up. And your existing appliance detects it. And once all the hosts are in, you can add it. So the only thing we have to do here is put in the passwords, because the pools we created were large enough, and if we didn't create pools that were large enough, we can simply add a new one here. It will tell you, you don't have enough IP addresses, create a new pool. Once you put in the passwords, you're done. 6 minutes, you've just increased your single appliance to a 2-appliance cluster. You can do that for 3 and 4 appliances. Simple as it. So that's the demo for me. I'm going to hand it back to Duncan now.
Well, I think we're actually going to open up the floor for questions.
Great.
So there's a couple of mics here on the floor. If anyone has any questions, please walk up to the mic so that the rest of the audience can actually hear you as well.
Am I correct to understand that there's a DNS server that comes with EVO Rail? And
yeah, it's a really lightweight internal DNS server. You can use it if you don't have external DNS. You can use it for fully qualified domain names, or you can use your external DNS service.
Okay, what DNS service is running on that?
It's a lightweight Java DNS service called Eagle DNS.
Okay, and so that gets updated as part of the platform when you do that.
Yeah.
Okay, awesome. Thanks.
Who does the support for Rail? Is it the OEM?
Oh, it's in the back. Yeah. Sorry. Go ahead.
Who does the support for Rail?
Oh yeah, that's a good question. So the support for the full appliance itself is done through the OEM. So the server vendor that you use to procure these systems through will do the support for all of the components which are included within the package. So that includes all the VMware components, but it also includes all of the hardware components that will come as part of the package.
Thank you.
My question, actually, I have 2 questions. The first one's on the network. A lot of these hyper-converged solutions just seem to have 2 10-gig NICs. And first thing that pops to mind is this kind of breaks the traditional best practice of separating vMotion as a jittery traffic and elephant flow, you know, and LAN and storage traffic. So I've never seen any discussion on how traffic shaping is enabled in this to prevent, you know, no traffic loss. So that's my first question. And my second question was, what about backup? You know, if I've got vRanger, for example, is that going to be able to back up the virtual SAN VMs? So the first one was on traffic shaping.
Yeah, so from a network perspective, what we actually did is we separated the traffic between the 2 NIC ports. So virtual SAN runs on the dedicated NIC port, and then all of the other traffic actually runs on the first NIC port. Now, from a traffic shaping point of view, what we did is we looked at vMotion, because we know vMotion can be quite bursty, and especially when you do maintenance mode, you need to move out 75 or 100 virtual machines. What we did is we actually limited the amount of bandwidth that the vMotion process can take on that single NIC. So we ensure that all of the other types of traffic will actually get sufficient bandwidth when it comes to the EVO Rail appliance. So that logic is built within the appliance. It's all part of the process.
That's awesome. And the backup question?
So the backup question, I'm not sure if vRanger, for instance, supports virtual SAN at this point in time. I haven't spoken to those guys in a long time, but I know there are various products out there. For instance, I know Veeam has support for virtual SAN. There's other backup problems as well that support virtual SAN.
Got it.
So that shouldn't be a problem in terms of backing it up.
Thank you.
So I have a question around the storage policies for VM. Like we saw in several other presentations surrounding VMworld, that you can have a policy attached to the virtual machine saying that I want my storage to be replicated, to be deduped. So how does those things fit into EVO? Because all you're using is the local storage, which probably does not have these capabilities.
So if you look at virtual SAN today, for instance, so the capabilities that virtual SAN offer you from a policy perspective is tweaking when it comes to availability. So you can specify the number of components that will need to be created, so the number of copies of your data. You can do things around performance as well. So you can specify, for instance, how many stripes of your data you would like to have, or what your read cache should look like. Unfortunately, as it stands today in the current version of virtual SAN, we don't offer any deduplication mechanism. This is something, though, that's being planned for future releases, so hopefully it will be solved in the near future. Now, the good thing about this is, if you look at the EVO Rail engine itself and the solution, we just leverage the capabilities that they offer us. So virtual SAN comes out with a dedupe engine or a compression engine, or whatever it ends up being, encryption or checksumming, it will be instantly included within the EVO Rail engine as well.
And how does this talk to the external world? If I have a different DR site, how can I move these VMs to a different site or replicate data across different sites?
So currently in the EVO Rail engine, there's no logic included to move virtual machines from site to site, because it's a quite complex process with multiple vCenter servers, potentially different types of storages, different types of networking. So you would need to use an external tool to move virtual machines from data center to data center. But if you look at the licensing, for instance, so vSphere application is included within the license itself. It's part of the standard license, so you can use that to start moving virtual machines between A and B. So that shouldn't be a problem.
Thanks.
All right. So I'm curious about high availability of these internal components. Like you just said that, you know, it's got 2 NICs and one of them is dedicated. So what's the sort of general philosophy around that? And then the internal things like vCenter and the EVO Rail engine, like is that a virtual appliance? Is that high availability, that kind of stuff?
Yeah, so let's talk about the hardware components first. If you look at it from a virtual SAN perspective, so the way that virtual SAN is configured is that every single virtual machine that's deployed will have multiple copies out there. So if one of the hosts will fail, then there's always still a host around that will have your data, right? So if the host fails, then your virtual machine keeps on running. If it's not running on the host that fails, of course. If it's running on the host that failed, then HA will actually just power it on another node. vSAN will detect that an error has occurred, and it will start spinning up new instances of your data. Now, if you look at some of the other hardware aspects, for instance, like the power supply, so it's a 2U unit, and it will have two power supplies, so you can actually run on one of those power supplies. So if an error like that occurs, that shouldn't be a problem either.
So is HA kind of tuned in a way that's smart enough to figure out that one of the nodes is isolated and it needs to evacuate and those kinds of things?
So if you look at vSphere HA as it stands today, it's deeply integrated with virtual SAN. So it actually knows the difference between an isolation or a partition. So if 2 of the nodes are partitioned, or if one of the nodes is isolated or one of the nodes has failed, HA will actually know what to do with that. On top of that, virtual SAN also contains a logic that allows it to figure out what has happened. So you can imagine that if you have 2 objects, you also need to figure out which of the objects actually should be used. So there's some form of quorum that actually sits within the cluster as well.
But that's not something you have to go and tune. It's kind of like that, right?
That's already done for you. So that's all part of the package. Virtual SAN actually takes care of that. We don't even need to take care of that. Now, from a EVO Rail perspective, so EVO Rail, of course, is just the process that runs within the VCVA, but there's also a watchdog around that. So if anything happens to the EVO Rail engine, the watchdog will pick it up and will restart the engine to make sure that from an availability standpoint and from a management point of view, you can still keep on continuing managing your virtual machines.
So first of all, really cool stuff. I think you guys did a great job.
Thanks.
The VCVA is particularly interesting to me. Where do you place the VCVA initially, and then afterward, is it then on vSAN storage?
Yeah, so that's a good question. The question is where we place the virtual, the vCenter server appliance. Is it on top of vSAN or is it on top of a local data store? That actually took us a couple of days to figure that logic out, and William Lamb helped us a lot with that. So what we actually do is the first node already has a virtual SAN data store created. Now, during the creation process, we actually changed the default policies which are part of virtual SAN to allow us to power on a virtual machine without having any type of resiliency. So the first host will contain the VCVA and also has a virtual SAN data store, and the VCVA already sits on top of the data store. Now the cool thing about that is, although it took us a couple of days to figure it out, you guys don't need to worry about it because we've already done the work for you.
Yeah.
And the partners will make sure that as soon as it rolls out to you guys, it just powers on and you hit the web page that allows you to configure it. So all of that smartness is done by the system.
So the policy will be changed to have more fault tolerant after the vSAN is configured?
Yeah, so that's part of the build logic. So you've seen the demo that Dave did. As soon as it goes through the configuration itself, at the end of the stage, what it will do is it will change the default the policy that's already available on the command line, and it will revert that back to have a fault tolerant policy. But on top of that, what we also do is we create a new EVO default policy. Yeah. And that EVO policy itself is something that you will see within the UI, and that policy is always attached to virtual machines. Because if you want to make a change to your policy, you will need to change the policy within the UI and not within the command line, because that would ruin the experience.
Thank you.
Time's up, I think. We've been told.
Let's take one more question and we'll wrap it up.
As it relates to hardware refresh, when one of these appliances go end of life, or say you have a cluster of 16, when it goes end of life, what does a hardware refresh look like?
So there's
an existing workload.
Yeah, so there's multiple options. If you look at the systems itself, so they will come with a 3-year support by default, both from a hardware point of view and also from a software point of view. If you wanna refresh that, it means you will need to add multiple nodes, and the only thing it will do from a vSAN point of view is place a host in maintenance mode and make sure you evacuate the data. That's the only thing you will need to do. So from a vSAN point of view, but even from a virtual machine point of view, that's a fairly simple process. Now, if you want to make sure, or you want to reuse the same hardware, there will also be options to actually renew your support as well on top of that. So you can keep on using the same appliance for an extended period of time.
Okay, thank you.
Okay, I think with that we conclude the session. Thanks everyone for attending.
Thank you for watching.